me check to make sure now how it goes there. Okay, that might be. Let's see. Maybe the audio's off on my phone. Okay, let's try that. Okay, that might be. Let's see. Oh, there we go. All right. So since you came, do you have any questions or? Oh, okay. All right. So let me kind of adjust things a little bit. And okay, so the aspect ratio of this thing is a little weird. Okay, so let's see if I tilt it a little bit. And I do not know how to get that thing off of the bottom. It just stays there. Oh, maybe this gets rid of it. I have no idea. All right. So we left last time with this being these being the equations that you need to use to find out information as far as the position, the velocity, the acceleration. So if you look down here, he does a decent job, although there is something missing here. Okay, so to really, the only thing we really need to look at, if someone were to ask us, okay, they would probably give us this information, but if you look in these equations, barring that maybe you don't have a z, the only thing you need to have is the r dot, r double dot. So you have r double dot here. Now, here's the thing. Oh, okay. Well, I might as well say this. Theta, you don't really see in these equations, but it is in there implicitly, and I'll show you what I mean. Then you have theta dot, and you have theta double dot. Oops. It basically saw something that wasn't there. It moved the screen. However, these two exist in the acceleration, but don't exist in the velocity. So let's try to find a problem and make all this kind of melt together. And I'll find the one, I'll take the one that I think I did. This one is one of the ones I think is in the homework. So I'm just going to grab it. Here, let's see. This, and then I guess I'll grab the whole thing. Right over here. Do this. Paste it. So if you look at this thing, he says, okay, the collars meaning this collar, meaning this collar and that collar, and they're pinned together they're pin connected at B, so there's a pin through those, and they're free to move along this rod, and they're free to move up and down that. Having a shape of a, I'm not even going to try to pronounce that, but here's the equation for it. R is equal to 0.2, 1 plus cosine theta, and here's the thing. At 30 degrees, which this looks like about 30 degrees, the angular velocity is this. Okay, now I wrote over that, but there's a theta, there's a dot there. So with that dot, that's one of the terms we're going to need. Determine the magnitude of the velocity of the collars at this point. Now, I'll go ahead and move to the right. I'm sorry, move to the left. So really, when you look at this thing, we have been given this, not that. We don't have that. So the question is, how do we deal with that? And it's pretty easy. And I'm sorry. Okay, so I can go ahead and take this one and I'll put it in front of that one and say theta dot times derivative of r with respect to theta. So, you know what, I'm going to write, well, yeah, I'll be fine leaving that as a constant there. Theta dot times the derivative of this, which actually could be written 0.2 plus 0.2 cosine theta. So you take the derivative of this, okay, and you have to remember you're taking the derivative of that with respect to theta. That term, here I'll even write it out explicitly, so, oops, and I'll put a parentheses because I need a 0.2 times the derivative of cosine theta with respect to theta. That term gives you nothing. This looks funny, but derivative of cosine is minus the sine. And this would be your r dot. Now I know that's a long process to get there, but that's okay. And then before I go back and address where this is occurring, I have to make it general. So in other words, I have this one. Now I have this one. I'm highlighting this because I'm not producing a well-organized document here. And so now I need to go in and take this, because this will be r double dot. So now I've got to be very precise how I put all these in here. So what I'm going to do is take this and stick it right in there the way it's supposed to be. And I'm going to go ahead and take the -2 and put it in front. So you know what I'm going to do? I know a minus and a 2 can come out. So minus 0.2 times the derivative, theta dot, sine of theta, with respect to time. Now, what's interesting here is one, that could be written or thought of as being a function of time. This one is just theta. So it's a little bit strange here. Now, I know he's only asking for velocity, but I'm going to go find the acceleration too. And what I'm going to also do is I'm going to make the assumption that the rate of change here is 0. In other words, this is spinning at a constant rate. So if I look at it like that, then I get I still get the minus 0.2. Now I get the derivative of this one times that one plus the derivative of that one times that one. And here, let me use the, is it still showing up there? Hang on, I didn't do that. And this might help too. I guess that stops automatically. Okay. All right. So is that a little bit better? Oh, it's tilting it off. Okay, here. I guess that's as good as writing on the board. I don't know. So here. So what I get is this times the sine of theta plus this times the derivative here. The problem is, well, first, there is no problem here. This is A-OK. This one is a little bit difficult because I don't have that particularly. So I need to make a little extra room here and then say, hey, wait a minute, I'll do this because I can find this. This is nothing more than theta dot, and so I get another theta dot I can put right here. So I get a minus 0.2 theta double dot sine of theta plus that theta dot plus that theta dot. It's two of them. So I get squared. And then derivative of the sine becomes the cosine, or is the cosine. Now, if I didn't make a mistake, did I make a mistake or did I? I don't know that I made a mistake, but I may have. If I did, you can correct me. Yeah, I'll tell you what, let me draw out the, oh yeah, but hang on. Okay, let me go back to the feed there, see if there's, okay, I'm going to put the volume down. We start it, okay, 11 minutes in. Okay. All right. So here we'll do, you know what, I'll go ahead and take a second, go back over. I'll do, since there's a few people online, let's see, Blackboard Learn. And I'll just hit the login. I'm surprised it didn't populate it for me. Oh, please. Oh, good. This is still spring. This is still dynamics. So the word of the day, let's see. This is mine. Now you enter yours, but let's see. And then second thing is I got to enter mine correctly. Bats. How about that? Okay, so I'll head back. Wait. Head back to where I was. Okay. I don't know why I just thought of that, but okay, so you end up with this. Now these are all, did I use a green there? I did. So these are all things that I will need, which actually, let me just do this. So now, how do we go and solve this? Well, the problem is interested, or the situation is interested. He is interested at 30 degrees. So what I'm going to do is I'm going to list everything at 30 degrees. And I'm going to do a theta, theta dot, theta double dot. There's only 6 things that you need to know. But you need to know them at 30 degrees. At 30 degrees, at 30 degrees. This is funny because theta at 30 degrees is 30 degrees. Now what he did, he told us the angular velocity there. Now I made the problem extra and said he's moving at a constant clip, so these are pretty much given. And in that light, let me do this. Or let me do it this way. I'm going to grab these. I'm going to move these on this side. I'm going to grab these because they're kind of self-contained. I'm going to shove them as far as I can over here. And then I'm going to focus on these. Okay, so what I'll do is I'll say, okay, these are kind of done. Now I got to work on these. So R at 30 is just equal to 0.2, 1 plus cosine of 30. I'll figure that out in a minute. Then this one's kind of hidden very quietly there, but it is minus 0.2, and that's what I'm grabbing right here. Minus 0.2 times theta dot. I think I'm going to do it symbolically first, and then minus 0.2. Theta dot, I can just grab and stick right there. So it's 3, and it's coming from the specification there, times sine of 30 degrees. And I'll figure all that out numerically in a second. Now, I'll grab this thing, stick it in there, minus 0.2, and I'm going to do it symbolically first, and then I'm going to put it in there. Oh, yeah, keep reminding me when that happens. I wish there was a timer that wouldn't do that. I don't know how to, there's probably a way to set that up, but okay. So theta sine, theta double dot sine, and then I got to get this, theta dot squared cosine theta. Now, underneath it, I'll put the values in. Now this one, I'm grabbing because I went ahead and said I want to find the acceleration too. So here I'm finding out it is not speeding up or slowing down. So this means that this is a constant. Stays 3 radians per second, continues 3 radians per second. And that's just me. I want to add the acceleration here. Sine, now there's no reason to put the 30 because it's times 0, but I'm doing it anyway. This is the same 3 that exist right here, and then cosine of 30. So now, I think I have octane in there. Let's see. Whoa, where did I put it? Let's see. There it is. So, give me a second, and I'll just put that in there. Okay. Minus 0.2 times 3 times the sine in degrees of 30 degrees. That's kind of interesting. Equals to minus 0.3. So there's that one. Oh. I put it in the wrong spot. Sorry about that. Minus 0.3. Here, I'll even complete that out. Equals to R. That's not what that one is. Okay. Go back to the octave. Okay, that was... Oh, that was where... okay, sorry about that. I read... Okay. Okay. That's on me. Let me fix that. so that was what that was. Now let me go back and do that one. 0.2 times 1 plus cosine degrees 30, and close the parentheses twice, gives me 0.37321. 0.37321 is equal to R there. Sorry, that's not supposed to be there. And then the last one, okay, I have to be careful here because it is true that's 0, but it's this times that times that. So I don't want to forget the other term. Minus 0.2 times 3 squared times cosine degree of 30. Oh, too many parentheses. Minus 1.5528 if I copied it right. No, 5588 equals to R double dot. So I got this one, I got that one, and I got that one. Now, just so we can have a memory here, that is the problem there, and that's great. But to me, it's scattered throughout the book, but this is one location where it's all in one fell swoop. Here's what I mean. I'm going to do this. I'm going to copy this. But this time, let's see. Wait. That's weird. It didn't do it. Okay. Did I not do the right thing? Let's try it again. Maybe I hit the wrong. Oh. I want to do what's called a free form. And what I'm going to do, I don't know how this is going to work. Okay. It looks a bit weird, but I am pasting it on a white background. So, it's very, okay, so it looks weird, and I'm sorry, but it is weird here. Yeah, it's good enough. It gets me the information I want. Okay. It looks pretty ugly, but I'll work off of it and then I'll remove it. So, as a matter of fact, one way I could do, here's how I'll work off of it. I will use a pen and trace it. I'll also increase the thickness of it. Okay. R is equal to RUR V R dot UR plus R theta dot U theta, which I'm have to put a bar. Acceleration is equal to R double dot minus R theta dot squared UR plus R theta double dot plus 2 R dot, theta dot, there's a dot there, U theta. And I think I did a decent job, so now I'm going to remove it. Now, I don't think we need that one, but we'll look at the first one. So, R dot, okay, so this is the velocity, R dot of minus 0.3 UR plus the R times the theta dot, 0.37321 times the theta dot of 3 U theta. I'll figure these numbers out in a minute. And then we'll try to make common sense of them. And then maybe I'll write under here. Here, hang on, I'll take off this jacket. I'm getting a little hot. And I did not bring my water with me. What was wrong with me? Okay, so our double dot minus 1.5588 minus R, which is 0.37321, theta dot, which is still 3. And so all I'm doing is I'm grabbing the appropriate values out of here, 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 and here. Even though there is a sixth one, it's never really written in these two equations. You don't find it in this equation at all, in this equation. Now, it is implied that it's there because you're evaluating these at 30 degrees, or at the theta. So, okay, I'm back to it. Now, close the brackets. UR plus R, which is again 0.37321, theta double dot. Okay, that one I self-imposed as being that. He didn't give that to us, but I want to make this problem complete. And if it was something else, if it was speeding up or slowing down, you'd just put it in. If it was 1, you'd just put in 1, and that would be it. Plus 2 times R dot, which is that. Then theta dot, which is 3. And then U theta. So let me look at something real quick just to double check. Okay. Did I forget my 2? I did write down my 2, didn't I? Yeah. Okay. I'm about to say, I thought I forgot my 2, but it's there. Now, before we go on, let's make common sense out of this. I should have done this earlier. Let's try to make common sense out of the R and the R dot. The R double dot is a little harder to make common sense out of, but let's look at the diagram and see if we can make sense out of it. When I say that, I've already junked up the diagram. So in fact, let me go grab the diagram again, and just the diagram itself. Nothing else with it. And we'll make it a little bit bigger so that, okay, let's do the square time this time. So I just want the diagram. I don't even need the equation because I'm just looking at the geometry here. And I'm going to put my pen right here, do a paste, and so it'll end up at the end of that pen, and I can move it around. So does it make sense? The diagram of this arc, it may not be perfectly accurate, but it does behave about that equation does pretty much behave that way. So if we're at 30 degrees, and that's, to me, that looks pretty close to 30 degrees. A few seconds later, the vector that points to that V is going to move to a shorter vector. So this vector is going to be shorter than that. Therefore, it makes sense that the R, the velocity of R, is moving in the negative direction. So that's shortening. So that's making sense. It also makes sense, this, if we start, maybe I should have included that. 0.2, 1 plus cosine theta. Okay, so if I look at this, here's my theta. That's of 0. This is of 90 degrees. And here's a 180. So if you move it yourself, now see if you go to the limit, you go all the way around to the other end, kind of makes sense. If you're at 180, this becomes 1 minus 1 gives you 0. So it does coalesce or drive down to this point. The second thing is, if you look at theta of 0, then you get this distance being 0.2. 1 plus cosine of 0 is nothing more than 1. So this distance should be 2 times that, or 0.4. That's how far that should be. So what's happening is, as you move along this path, the r is shortening. But it makes sense. I mean, the limit, r should never be, it should never be, here, r is going to exist, how about that, between 0 and 0.4. It should never be greater than 0.4, and it definitely can't be, a length can't be less than 0. So in fact, 0.37 makes pretty good sense. So if that's 0.4, you're saying that's 0.37. So the geometry and everything makes common sense. The answers look okay. I'm not going to go into any further detail there, but at least it's good to look at the geometries to make sure it makes sense what you're getting. So what I'm going to do is I'm going to do something extra here. It's 9:35. I've got enough time to do this. So what I can do is multiply this out and multiply this one out. And I get a number. So I'll get a number times UR plus another number times U theta. But what I'm going to do is I'm going to focus on this one. And I'm going to actually get the numbers out of it. I'm going to show you something interesting here. Okay, so obviously the first one is 0.3 UR. And the second one is 3 times that other number. Uh-oh, wait a minute. 3 times 0.37321. 1.1, okay, 1, uh-oh, 1, where did it go? Oh, wait. 1.1196 U theta. Okay, so let's just reset our brains to, oops, that didn't look right, to saying someone told you the velocity is equal to minus 0.3 UR plus 1.1196 U theta. Now your first thing is like, okay, I'm done. But let's take it one step further. And let's say now somebody's asking you, and hint, somebody will ask you, what is this value as far as I and j is concerned? Now, how do you get that? If I were to have a vector, okay, so let's look at this vector first, and let's see if we can make sense of it. Looks like if I multiply that number, the absolute value of that number, I get about that, right? Is that about right? Okay, so I'm just trying to make sense of it. From 0.3 times about 4, pretty close, a little bit shorter. So I'm just trying to get a scale here. Here's what I'm trying to do. I'm going to copy this. I'm now going to slide it down here. I'm now going to increase its size a little bit. And now I'm going to look at the geometry of this thing. Okay, the geometry says, okay, here's my base vector. One base vector goes out here. You may not be able to see this that well, so here, let me change to here, black, okay. Well, you can't see that well either because the dot's kind of small. Here, let's go to that. Get to the path. Uh-oh. It looks like we went offline for a second. Okay, I'm sorry if we went offline. guess my network is still reconnected. Okay, it went off, disconnected, and reconnected. Okay, it looks like we went offline and came back. The key is the velocity is tangent to the path. This is your path. So it looked pretty close. But now if I put this coordinate on here, X and Y, I have a different story. How do I find it? Well, it comes back to, I got 10 minutes to do this. It comes back to how does UR related to I and J? And we did that before, in which here's your I, here's your J, here's your UR. You have to remember they're all unit length. So this means you get cosine theta. So if I take this vector, which changes with respect to theta, but I'm bringing it back to the I and the J, I get this. Now, move a little bit. I thought I could move to the right. Okay, here, do like that. Now I can move to the right. Maybe. Good. Okay, so now let's take a look at my U theta. There's my I, there's my J. This time my U theta kicks back at that theta. So again, it's got a vector and components, and U theta is going to be moving backwards sine I and up cosine theta J. Looking at it a little closer, try to do a little bit better job here. In other words, this vector, this is theta. It's of length 1. So this component going in the I direction, it's going backwards, and it's the sine of theta. The distance from here to here, same as here to here. If I want to know the component going in the J, it's just simply cosine of theta. I'm sorry, I said, yeah, so here's this one, here's that one. So now all I have to do is recognize that if I wanted to expand this, all I have to do is take the UR, let me go back to a different color. I take my UR and my U theta, and I say minus 0.3. Now replace UR with that cosine. Now my theta is 30, and it stays 30 throughout, plus 1.1196 times the U theta. I'm sorry, the UR went here, the U theta went here. I may have spoke differently there. 30I plus cosine of 30 in J. Now, if you multiply all this out, you'll get minus 30 cosine 30. I'm sorry, 0.3 times cosine 30. Minus, because I'm going to grab this and this one, 1.1196 sine of 30 times I. I'm gathering the I terms. In other words, here's my I. Here, I'll do it this way. Here's my I. And here's my J. And I haven't written my J up here yet, but I will in a second. Plus the components and the J. So here. Now grabbing the components of the J would be minus 0.3 sine of 30, and then plus 1.1196 cosine 30. And so the cosine and this goes there. So that's how you convert between the two. So this brings up the point that, in fact, the theta is very heavily dependent, or let me rephrase that. The UR and the U theta are dependent upon theta. So in other words, as theta moves around, so too do these, and they're dependent through these angles. And I did that in 5 minutes, and I didn't complete the multiplication, but that would have slowed me down quite a bit. But you can go do that if you want. And I think I assigned this one somewhere in the homework or the midterm or the final. I will be releasing that next week, and I'll send you an email. So now I'm tired. So I am thirsty. So if y'all don't mind, I'll go. Let me see if I can figure out how to stop this thing. I hope it didn't stop too much in there. I think it's still going. Let's see. It apparently had a hiccup.